Just want to explain what red and infrared light and the wavelengths are. So we know that red and infrared are part of the visible light spectrum. Well, red light is. So here we can see blue, green, yellow, red and infrared light and the penetration, the depth that they go through. We know that the shallow end of the spectrum is high energy and only penetrates maybe into the epidermis. We can see here the cross-section of the structure of the skin. So each wavelength will penetrate and absorb into different structures. The deeper wavelengths require stronger power and they need to get through to the deeper structures. So we do know that shallow wavelength is high energy and the deeper is lower energy with a longer wavelength. And as it passes through the skin, the tissue, we know that light is penetrated and absorbed. We can apply light in two ways. We can do it via a laser, a coherent light, or LEDs, which is an incoherent light. Lasers are high powered and require safety goggles and a professional to apply them. LEDs are very safe and used in many areas. Now here you can see a graph cross-section of the absorption versus the wavelength. So the longer the wavelength, the absorption of the light into the different chromophores is evident. So in the shallow tissues under the 600, we can see that melanin and hemoglobin and oxyhemoglobin are highly penetrated and highly absorbed. As we go deeper, water becomes the main chromophore, and this is why we use the deeper wavelengths. Here we can see the effect of red light hitting the mitochondria cell. We get a change in increase in nitric oxide, we get ATP increase, and we get a cascade of cellular reactions causing gene transcription. And the main thing about that is that we get an activation of cells, but the biggest action we have is the increase in pro-inflammatory cells. So what we want is the inflammation is cleaned up, and that can help reduce pain. So analgesia comes with an inflammation reduction. The cascade of cellular reactions is quite complex, but in a nutshell, when light hits the membrane of the mitochondria, the outcome is this cascade of cellular reactions. And the target is different at different levels. So muscle strain, we can have reduced inflammation, we have less swelling, reduced muscle fatigue, and increased healing time. In combination with proper movement and correct rehab, red and infrared light can have a significant input. Same with tendon injuries. The red and infrared light in particular can activate collagen regeneration through the gene transcription. That in combination with correct tendon loading program, you can have significant results in tendon repair. We can also apply light to the spine, although the structures are a lot deeper, and certainly to get there requires more power, but there is evidence to say that it is very good for the inflammation. So we have analgesia, and that is explained through the activation of the mitochondria by the light, and the outcome is that we have reduced inflammation, and this gives us reduced pain. So that's one of the significant effects of the light. We also have increased healing, so that means reduced healing time, and this is very important when we're looking at people returning to sport or returning to work, and the same with our equine athletes. Light, ice versus PBM, there's a big swing around now that ice is out and light is in. Ice shuts the whole metabolic process down and light increases the activity. Now, a lot of research, 5,000 new papers over the last 10 years, we have been able to find that red and infrared light has significant benefits for every part of the body, and it's certainly been taken up by very many medical fraternities. Now this pad I've designed for a horse. It has 3 wavelengths, 660, 810 and 980. Therefore, it can get deep through the melanin and the hemoglobin into the deeper tissues and be very effective. And the brand that I have instigated is Red Light Physiotherapy.